Kia ora and thanks for watching this video going through how to do exercise 3D. I'm sorry I'm away sick today, but I wanted to just send this in so that you have a worked example or two to go through. So what we're going to do today is this incredibly cool little piece of trig, which is this, that we can take an expression a cos x plus b sine x, so two separate cos and sine functions, and we're going to rewrite it as one cos or sine function. And you can see already that it's going to use my compound angle formulae. Now you should be getting pretty comfortable with those now, and we're going to do a little bit of revising those along the way. So here's the first example. We're going to write 20 cos theta plus 21 cos theta in this form here. So the first thing I'd like you to do is to pause the video and, either working on your own in pairs, just write down what this compound angle formula gives us. So we have r cos theta minus alpha, so off you go. Write that out. Okay, so you should have had this. R cos theta cos alpha plus R sine theta sine alpha. Now you were prompted here which form to go into. You were told to go to R cos x minus alpha, but you might be able to see why that makes sense. And it's because here I've got a plus, and in here I've got a plus as well. So, having a look now, we're back to basically year 11 trig from here, maybe even year 10. I want you to think about matching up some coefficients. So we've got 20 cos theta here. We've got 21 sine theta here. So we're trying to get it into this form here. So think about what that 20 is in here and draw some triangles. When you're doing these problems, you already know I'm going to say this, but always draw the little right angle triangles. So try that now, pause the video. I'm going to go through it really slowly on the next slide. Okay, so what have we got? Well, the first bit, we've got r cos, so I'm just matching up the coefficients here, r cos alpha has to equal 20. And then r sine alpha has to equal 21. So hopefully you're seeing that, hey, that looks just like year 10. So let's draw our little triangle. I think in the question you also got told that alpha was in the first quadrant. So let's just make it in the first quadrant for now. So what have we got? Well, really slowly we can rewrite cos alpha is 20 over r. So here's alpha and here's 20. This is r. Right, not looking very good so far. But then we see that we've also got r sine alpha is 21. So we've got sine alpha is equal to 21 over r. So this is the opposite over the hypotenuse. So this is 21 here. So that lets me work everything out. I can figure out r from Pythagoras. So r squared is 20 squared plus 21 squared. And r is equal to the square root of that, which is 29. Alpha is equal to, well, I can choose, I'm going to use inverse cos. Cos inverse 20 over 29, and I'm going to round that to 1 dp. So that gives me 46.4 degrees. So I'm just going to insert another slide to finish this one off, then we'll do one more. Alright, so my answer is this, 20 cos theta plus 21 sine theta is equal to 29 cos theta minus 46.4 degrees. Now, at the weekend I made a nice GeoGebra thing to show you what that looks like. I'm going to try and upload it into Google Classroom, if I can get that to work from home. But I'd like you to either go onto your graphics calculator or go onto GeoGebra yourself, because it's so easy to use. It's so good for helping your understanding. So go to geogebra.org, and I want you to graph this plus this first. So add those together, two separate sine functions, and then graph this, and you'll see that they work out to be the same thing, which is really, really good. Okay, next example coming up. It uses one of the other compound angle formulae. Right, so this time I picked one that is a sine one. We generally have a fair bit of choice about what we do, but here we've got a sine theta, root 3 sine theta, minus a cos theta. So we're going to pick this form of compound angle formula, because here's what we've got. We've got root 3 sine theta. I'll do this one a very slightly different working. Minus cos theta is equal to r sine theta minus alpha. Now, I'm sorry for the shocking production quality of this video. I'm not even using a stylus, so it's pretty ropey, but that's better than nothing. So we've got root 3 sine theta minus, I'll put in a 1 there, 1 cos theta. Now, expanding this out, we get r, remember how this works, it's going to be r sine theta cos alpha minus r cos theta sine alpha. Oop, run out of room. There we go. Okay, so off you go, pause the video, and now what you're going to do is you're going to match up the coefficients and draw your triangles. You've got root 3 is equal to r cos alpha, and you've got 1, not negative 1, but just 1 is equal to r sine alpha. So let's do the triangles on the next slide, and you should be spotting a special triangle about now. Okay, so let me find the wee example. Okay, so what do we have? Well, we've got r cos alpha. Cos alpha is equal to root 3. So cos alpha is root 3 on r. Drawing my triangle, there's root 3, there's my right angle, and there's r. So here's alpha. And what's sine alpha? Well, we've got r sine alpha is equal to 1. So there's 1. So sine alpha is 1 over r. So you don't strictly need this step, right? But I think it makes it easier to link it back to a really easy trick. So we can solve that now. And using Pythagoras, we're going to get that r is 2, right? Better put some working in for that. Right, so r is equal to root 3 squared plus 1 squared, square rooted. So r is 2, and we know from our special triangles that alpha is equal to pi on 6. So our final answer, and I'm going to be really bad. Oh no, I am going to write out the whole equation because I can't not. Okay, so we've got root 3 cos theta minus sine theta is equal to 2 sine theta minus pi on 6. Alright, thanks for watching. Have a go at exercise 3D, and do go on to GeoGebra or your graphics calculator and see graphically what's going on. And I'll see you next week.